The TOR network, short for the Onion Router, is a decentralized, anonymizing network designed to protect users' privacy and enable censorship-resistant communication by routing internet traffic through a series of encrypted relays, obscuring both the origin and destination of data transmissions. Originally developed in the mid-1990s by the U.S. Naval Research Laboratory to safeguard government communications, TOR was later released as open-source software and has since evolved into a global privacy tool used by journalists, activists, whistleblowers, cybersecurity professionals, and everyday individuals seeking to evade surveillance, bypass geo-restrictions, or access the internet without revealing their identity. At its core, TOR operates on the principle of onion routing, a multi-layered encryption technique where data is wrapped in successive layers of cryptographic protection, like the layers of an onion, and passed through at least 3 randomly selected volunteer-operated relays or nodes before reaching its final destination. Each relay in this circuit decrypts only a single layer of encryption to reveal the next hop in the path, ensuring no single node knows both the source and destination of the traffic, thereby preventing any entity from tracing communications back to the user. The first relay, known as the entry guard, sees the user's real IP address, but cannot decipher the content or final destination due to encryption. The middle relay simply passes along the partially decrypted data without access to either endpoint, and the exit relay, which delivers the traffic to the public internet, knows the destination but cannot link it to the original sender. This architecture makes TOR exceptionally resistant to traffic analysis and network surveillance, though it introduces latency due to the multiple hops and encryption overhead, resulting in slower browsing speeds compared to direct internet connections. Beyond anonymizing web browsing, TOR supports hidden services through its .onion domains, which exist exclusively within the TOR network and enable fully encrypted, peer-to-peer communication without exposing server IP addresses. These hidden services are pivotal for whistleblowing platforms like SecureDrop, privacy-focused websites, and controversial marketplaces on the dark web, where both legitimate and illicit activities coexist due to the network's strong anonymity guarantees. The TOR Project, a non-profit organization maintaining the software, emphasizes ethical use cases, such as circumventing state censorship in authoritarian regimes, protecting journalists' sources, or securing communications for human rights workers, while acknowledging the challenges posed by malicious actors exploiting the same privacy features for illegal activities. To balance accessibility with security, TOR offers multiple entry points. The TOR browser, a modified Firefox version pre-configured with privacy extensions like NoScript and HTTPS everywhere, simplifies anonymous web access for average users, while advanced configurations allow tunneling other applications through TOR via SOX proxies or the TOR daemon tor.x for system-wide anonymization. The network's resilience stems from its decentralized structure, with thousands of volunteer-run relays distributed globally, making it difficult for adversaries to compromise the entire system. However, TOR is not impervious to attacks. Sybil attacks, where an adversary controls multiple relays to de-anonymize users, timing correlation attacks, matching traffic patterns at entry and exit points, and malicious exit nodes, which can intercept unencrypted traffic, represent known vulnerabilities. To mitigate these risks, TOR implements guard nodes, long-term entry points to prevent Sybil-based tracking, circuit padding to obscure traffic patterns, and encourages the use of end-to-end encryption, like HTTPS, even within TOR. Law enforcement and intelligence agencies have occasionally compromised TOR users through operational security failures, for example, browser exploits or user mistakes, rather than breaking the protocol itself, underscoring that anonymity depends on both technology and user behavior. TOR's impact extends beyond individual privacy. It serves as a critical infrastructure for censorship circumvention in countries like China or Iran, where governments block access to foreign news and social media. Tools like OBF's 4 bridges disguise TOR traffic as innocuous data to evade deep packet inspection, DPI, while Snowflake allows volunteers to proxy connections through temporary browser-based relays, making block lists obsolete. For researchers and cybersecurity professionals, TOR provides a sandbox to study network anonymity and attack vectors, contributing to broader advancements in privacy technologies like zero-knowledge proofs and mixed networks. Ethical and legal debates surround TOR, with proponents advocating its role in preserving civil liberties and critics highlighting its misuse for criminal markets, for example, Silk Road, hacking forums, or malware distribution. The TOR project collaborates with researchers to improve security while resisting backdoors, arguing that weakening anonymity for some jeopardizes it for all. As surveillance capitalism and state-sponsored monitoring escalate, TOR remains a vital countermeasure, though its future hinges on sustaining volunteer relays, which face legal pressure in some jurisdictions, and adapting to quantum computing threats that may challenge classical encryption. In an era of eroding digital privacy, TOR exemplifies the tension between individual freedom and collective security, offering a technically sophisticated, if imperfect, shield against the pervasive tracking that defines the modern internet.